All right, so now we're going to go back to our 7.2 lesson. Let's see if we can make this intro video a little shorter than your last intro video, which was quite long. Just one lesson today, so date over there and then figure out what page you're on in your notes, which will be different for each of you, and that goes over there. So scientific notation, this slide, I have this in here just because this is part of what you have to do in your homework. So I just want you to understand when the book asks you to do this, what are they saying? So find the value of each power of 10. So all we have to do here is we move the decimal around, but we just have to know where to start. When it says 10 to the third power, you start with 1. It's 1 point right there, that's where the decimal goes. And a positive exponent means we want a bigger number, so you're going to move your decimal 3 spots to the right, 1, 2, 3, and that will get us the bigger number, and you fill in your zeros. So 10 to the third power is 1,000. All right, 10 to the negative 4, again, start with 1, and this time it's 1 point. Because it's a negative 4, negative exponents give us smaller numbers. So you're going to move your decimal 4 spots to the left. So here's 1, 2, 3, 4. Fill in your zeros. You can fill in 1, 2, 3. So we have 0.0001. So on these, what we're doing is we're starting with 1 and figuring out where to move the decimal. So 1, I guess with 1 point. Now 5, positive. Make your number bigger, move it 1, 2, 3, 4, 5. Fill in your zeros. This one's going to have 5 zeros. 1, 2, 3, 4, 5. 100,000. And then last we have 10 to the negative 7. So start with 1. Move your decimal 7 spots to the left to make your number smaller. 1, 2, 3, 4, 5, 6, 7. That's going to be 6 zeros. And then a 1. All right, so when you're finding the value of powers of 10, start with 1 and move your decimal. All right, so now when you write each number as a power of 10, you just want to figure out what should your exponent be. So this is going to be 10 to some power. Now because it's a decimal, that means that we want a negative exponent because small decimal numbers get negative exponents. So you just have to put the decimal back where it goes, right there, and that's moved at 1 spot, so it's 10 to the negative 1 power. All right, our next one, we're going to write it as 10 to some power. Again, because it's a decimal small number, it's going to have a negative exponent. So we just have to get the decimal where it goes, 1, 2, 3, 4, 5, and see how many times it took to do that, so negative 5. All right. 100 is a big number, so we're going to have a positive exponent, so it's going to be 10 to some positive number, and we want the decimal to be after the 1. Right here it's on the end even though they didn't write it in for us, so 1, 2, 10 to the second power. 10 squared is 100. And then last one, 10 to some power. This is a big number, positive exponent. Decimals at the end, let's move it to the 1, 1, 2, 3, 4, so 10 to the 4th power. So when you see those in your homework, that's how those work. All right, so express each number in standard form. So standard form is kind of what you're looking at right here. Well, no, it's not what you're looking at. Where's my eraser? Went away. It's not going to let me erase that. Okay. So standard form is going to be, we take the number out of scientific notation. So what you do is you take, this is 3.78 times 10 to the 5th. So all you do is you take your 3.78 and you're going to move your decimal. Because this is a positive 5, that means that you want a bigger number. So positive exponents give us big numbers. And to make this 3.78 bigger, we're going to move our decimal 5 spots to the right. So 1, 2, 3, 4, 5, and you fill in zeros. So our final answer is going to be 378,000. 378,000. That's standard form when you take it out of scientific notation. All right, next one, 4.1 times 10 to the fourth. So you start with your 4.1 and then take a look at your exponent. That's a positive number, so we want this positive exponents give us big numbers. So we're going to move our exponent 4 spots to the right to make it bigger. So here's 1, 2, 3, 4, and you fill in your zeros. So we have 41,000. All right, now this one over here where I couldn't erase the line I drew, you have 1.25. Now this is times 10 to the negative 3 power. So negative exponents give us small numbers. So if you can remember, positive exponents equals big numbers, negative exponents equal small numbers, then you'll always know where to move your decimal. So how do we make this number smaller? You take your decimal, and if you move it to the left 1, 2, 3 times, it gets smaller. So decimal goes out at the very beginning, and you fill in 2 zeros, and then you've got your 1, 2, 5. All right, next one, we have 9.623 times 10 to the negative 7th power. So negative means we need a small number, and we're going to move our decimal to the left to make our number smaller. So there's 1, we have to move it 6 more times. 2, 3, 4, 5, 6, and you fill in all those zeros. I don't think I filled in enough, I'm missing one. 1, 2, 3, 4, 5, 6. There you go. So when you write your final answer, you have 6 zeros, and then 9623. So there's your standard form. All right, so now you have to get our numbers that are in standard form and write it in scientific notation. So 2 things you want to focus on in these. One is, where does your decimal go, and should you have a positive or negative exponent? So the decimal is always going to go after the first significant number, or first significant figure, I think is how they say it in a science class. So you have 223,000. Your decimal is going to go after the 2. So I'm going to have 2.23. And I can kind of ignore all those zeros on the end. This is going to be times 10 to some power. Now because 223,000 is a big number, I want a positive exponent. And all you have to figure out is to get the exponent from the end to kind of count exponent at the end, period at the end, decimal, to the decimal right here. How many spaces in between? 1, 2, 3, 4, 5. So positive 5 power. All right, next one, we have a decimal. So that's a small number, which means we're going to have a negative exponent. And then where is it going to go? From left to right, you have to go after that first number that's not a 0, basically. So it's going to go after the 1. So we're going to have 1.54 times 10 to some negative exponent. And then here's the new decimal. There's the old decimal. How many spaces in between? 2 of them. So negative 2. All right, look at this huge number, 98,700,000. So this is a big number. It's going to have a positive exponent. Where does your decimal go? It goes after the 9. So we're going to have 9.87 times 10, and then just count up the spaces between the new decimal and the old decimal at the end. So you have 1, 2, 3, 4, 5, 6, 7. Last one on this slide, you've got this small decimal number. It's going to give us a negative exponent. Where does our decimal go? It goes after the 8. So you have 8.245 times 10 to the negative, and then how many spaces in between your two decimals? 1, 2, 3, negative 3. So that's taking standard form numbers and putting them into scientific notation. All right, here is our last slide for our intro video.
this we have to use our exponent properties for, and you'll see why when we run through these. So if you multiply two scientific numbers together, they get multiplied right there. The only thing you actually have to do is multiply the pieces that go together. So the 4.2 would get multiplied by the 2.0. So 4.2 times 2.0 is 8.4. And then what you're going to do is you're going to multiply your tens. This is where your exponent property comes in. If you're multiplying the same base, you keep the same base. So I'm going to say times 10. I'm keeping the 10. And then what do you do with those exponents? You're going to add them. 4 plus a negative 7 is negative 3. And there's our answer in scientific notation. So scientific notation, that's the only time that a negative exponent is okay in your answer. All right, here's our next one. We're going to multiply these. Again, multiply the pieces that seem like they go together. 1.2 times 3 is a 3.6. And then multiply your tens. If you're multiplying the same base, you keep your base. So I'm going to say times 10. And then add those exponents. Negative 3 plus 5 is a positive 2. And that one is set. All right, now these with division, kind of like the multiplication, divide the pieces that go together. 4.2 divided by 2.0 is 2.1. And then over here, if you're dividing the same base of 10, you keep your base of 10 and subtract your exponents. So 4, this one's a little tricky because it's 4 minus a negative 7. So when you subtract a negative number, it actually becomes a positive. You end up adding and you get a positive 11. All right, last one. Divide the pieces that go together. So 3.6 divided by 1.2 is 3.0. Oh. And then divide the tens. When you divide the same base with exponents like that, you keep your 10 and then subtract the exponents. So you're going to do a negative 5 minus the 3, which becomes a negative 8. And that's our lesson on scientific notation.